Good morning everyone. Welcome again in the physics class of refraction through a lens. Firstly, I will discuss about syllabus. Children, lens converging and diverging including characteristic of the image formed using ray diagram only. Magnifying glass, location of images using by diagram and thereby determining magnification. Scope of syllabus, types of lenses, converging and diverging, convex and concave action of lens as a set of prism, technical terms, center of curvature, radius of curvature, principal axis, focal plane and focal length, etc. Children, and also power of a lens, concave and convex, simple direct numerical problems, magnifying glass or simple microscope, location of image and magnification of from ray diagram, formula and numerical problems, not inclined application of lenses. Children, first I will discuss lens and refraction of light through a lens. What is lens? What is lens? It is a piece of transparent glass bound by two spherical surfaces and is used to magnify objects. It is called as lens. And also refraction of light through a lens. What is the meaning of refraction of light through a lens? Refraction is the change in direction of light when it from one medium to another. The working of a lens is based on the refraction of light when they pass through it. Okay, children? Now I will discuss lens. Children, a lens is a transparent refracting medium bounded by either two spherical surface or one surface spherical and another surface plane. Okay, children, a lens is a transparent refracting surface. We know that refracting means light comes from incident ray or rarer medium to denser medium. It is called as refraction. Otherwise, refraction is the bending of light. It also happens with sound, water and other waves as it passes from one transparent substance into another. This bending of refraction makes it possible for us to have a lens, magnifying glasses, prism and rainbows. Even our eyes depend upon this bending of light. Very important definition, children. Lens. A lens is a transparent refracting medium bounded by either two spherical surfaces or one surface spherical and other surface plane. For example, two spherical surface means this is spherical surface. It is lens. Convex lens. It is convex lens. How many types of lens? That is two types of lens. Convex or converging lens and concave or diverging lens. Important point, convex or converging lens and concave or diverging lens. Children, what is the meaning of convex? Convex means curved or round. Curve or round. Just for example, curve or round. Right? Curve or round. The convex means curved or round outward like the exterior of the sphere of or circle. Concave means next concave or diverging lens. Concave means having a surface that curves towards the inside the something like the inside a bowl. For example, it is the concave lens. Converging lens means to move towards each other to meet at the same point from different direction. For example, this is principal axis, it is lens, parallel line, that is incident ray comes parallel to the principal axis, and strike to the convex lens. Then it bends by the lens to the principal axis is called as the focus. It is the focus. The bending of light or to move towards each other or meet at same point from different direction is called as converging lens. So both parallel line are converged to the focus. Similarly for diverging means to separate and go in different direction or to be or become different. For example, it is the principal axis, it is the normal. Once again, parallel, it moves in direction and backwards, it is the focus. Okay, so diverging means to separate and go in different direction or to be or become different. Okay, how many types of convex lens or converging lens? That is 3 types: biconvex, second plano-convex, concavo-convex. Okay, next concave or diverging lens. It is the convex lens, it is the concave lens. A concave lens is thick at the periphery and thin in the middle. In other words, a lens which is bent toward inwards in the middle is the concave lens, such as a lens diverges the light rays incident on it, and it is also called as the diverging lens. Therefore, concave lens may be of the following 3 kinds: biconcave, plano-concave, or convexo-concave. Okay, children, I will discuss very important part: converged action of convex lens. Converged action of the convex lens. Let us consider this diagram. Let us consider the refraction of parallel rays of light A, B and C, right? incident on the prism or lens respectively in the upper, central and lower parts. Upper part, lower part and center part. Okay. We know that a ray of light incident on prism on refraction through it always bends toward the base of the prism. Towards base of the prism. It is the bending point. It is the bending point. Always bends towards the base of the prism. Therefore, the prism in the upper part of convex lens bends the incident ray A downwards, while the prism in the lower part of the convex lens bends the incident ray C upwards. From this to this side, this to this side. Okay. The central part, which is parallel side glass slab, passes through ray B, normally incident on it, undeviated. That is B line, B ray is undeviated, and A is deviated and C is deviated. Thus, the set of prism forming a convex lens converges the parallel rays to a point F. To a point F. Therefore, a convex lens has a converging action on the incident light rays. Incident light rays. It is incident, it is incident, it is incident. Incident ray, that is coming rays, is called as incident ray, and going rays is called as the refracted rays. So therefore, incident ray, it is incident ray and it is refracted ray. Okay. Thus the set of prism or lens forming a convex lens converges the parallel rays to point F. Therefore, convex lens has converging action on the incident light rays. It's called as the focus. So F is the focus. Okay. Now we consider the diverging action of concave lens. Here, in this figure, the prism in the upper part, prism or lens in the upper part of the concave lens bends the incident ray A upwards, towards its base, while the prism in the lower part of the concave bends inside the ray C downwards. It is downwards. Okay. The central part, which is parallel side glass slab, passes the normally incident ray B undeviated. B is undeviated. Okay. Thus the set of the prism forming a concave lens diverges the parallel rays as if they are coming from a common point F situated on the side of rays incident on the lens. Therefore, a concave lens has a diverging action on the incident rays, right? That is incident. It is the diverging point that is represented by, F, focus. Okay. Now children, next part, technical terms related to a lens. What is the center of curvature? What is the center of curvature? The center of curvature of lens is the center of the sphere of which the mirror is a part. Mirror or lens is called as the center of curvature. It is center of curvature. Both spheres. This is the principal axis. This is the principal axis. And C1 and C2 is the center of curvature. C1 and C2 is the center of C1 and C2 is the center of curvature. Same process for concave lens. C1 and C2 is the center of curvature. This line represents principal axis. Okay. So center of curvature means the center of the sphere whose the part is the lens surface is called the center of curvature of that surface of the lens. That is C1 and C2 is the center of curvature of the concave lens or concave lens. And O is the optical center. O is the optical center. O is the optical center. Okay. What is the meaning of radius of curvature? PC1, children. PC1, this side, P2C2, P1C1, P. Radius of curvature. The radius of the sphere whose part is the lens surface is the called as the radius of curvature of that surface. Therefore, PC1, PC2 is the radius of curvature. It is the R1 and it is the R2. R1 is the first radius of curvature. R2 is the second radius of curvature of the second part of sphere. Same process for concave lens. Children, PC1, P1C1, P2C2 is the radius of curvature of the concave lens. Okay, children. Next, principal axis. Principal axis. This line represents principal axis. It is the line joining the center of curvature of the two surfaces of the lens. The line C1 and C2 is the principal axis. It can extend it on either side of the lens. That is, it is the principal axis. It is the principal axis. Okay? Understand it up? And optical center. O is the optical center. So what is the meaning of optical center? It is a point. O is optical center. It is a point on the principal axis of the lens such that a ray of light passing through this point emerges parallel to its direction of incidence. It is marked by the letter O. It is marked by letter O. It is the optical center. The optical center is thus the center of the lens. Center of the lens. Okay. Now I will consider next point. Convex lens and concave lens. Generally, the lens, concave lens, generally the lens is thin or thick. So the lateral shift is small. Generally, the lens is thin. So the lateral shift is small enough and it can be ignored. Therefore, a ray of light is directed towards the optical center of the thin lens can be considered to pass through the lens undivided and undisplaced as shown this diagram. Undisplaced. And this concave lens and convex lens. It is undivided. If any rays pass to the optical center, then this ray will be undeviated or undisplaced. Okay, children? Now I will consider to this part, that is the first focal point. First focal point for a convex lens, the first focal point is f1. On the principal axis of the lens, such that the rays of light coming from it after refraction through the lens, this to this, okay, and this is principal action. So for a convex lens, the first focal point is a point f1 on the principal axis, on the principal axis of the lens, such that the rays of light coming from it after refraction through the lens become parallel to the principal axis of the lens. Okay, children? Now same process consider concave lens. For a concave lens, it is the concave lens. First focal is a point f1 is this side on the principal axis of the lens, such that the incident rays of light appearing to meet at it after refraction from the lens become parallel to the principal axis. This light rays come and bend from this side, and this light comes and bend from this side. If merges, that it cuts to f1 point. Okay, for a concave lens, first focal point is a point f1 on the principal axis of the lens, such that the incident rays of light appearing to meet at it after diffraction from the lens become parallel to the principal axis lens. Same process for second focal length f2. For a convex lens, the second focal point is a point f2 on the principal axis of the lens, such that the rays of light incident parallel to this, the principal axis, after refraction from a lens pass through it, that is f2. Okay, after it is the refraction point. f2 is called as the second focal length. Same process for concave lens. For a concave lens, second focal point is f2 on the principal axis of the lens, such that the rays of light incident parallel to the principal axis. It is the principal axis, incident ray. Okay, it is the principal axis, incident ray comes and diverted to this side, incident ray comes and diverted to this point, it moved to the back side and it cuts to f2. f2 is the second focal point. Okay.